Assalamualaikum and hi to all of you. Today I want to present about our group project, Load Bearing Straw Tower. We are from Group 6, Solid Mechanics Section 1. Our lecturer name is TS Dr. Noraini binti Marsi. These are our group members. First, Raja Aminuddin bin Raja Faisal, Siti Nurshaqila Natasha binti Sharuzee, Mohamad Aiffan Nazim bin Abdullah, Khalishwarr anak lelaki Kartigasoo, and me Muhammad Akmal bin Baharum. Now we continue to the introduction.
Assalamualaikum. Welcome and hi, my name is Raja Aminuddin bin Raja Faisal. My metric number is AN2000091. The project we did is to build a tower using a drinking straw. Let me start with introduction. As we all know, straw was invented to make it easier for humans to drink water. The straw has a structure of small hollow tube that made from plastic, or to be specific, we call it as polypropylene plastic. Okay, so this is the example for polypropylene plastic that we can see in our daily life. Polypropylene is a thermoplastic, which is addition of polymer made from the combination of propylene monomers. So the features that has on polypropylene plastic is it is heat insulator, waterproof, not easy to rot, lightweight, and great surface hardness. So we continue back to the our topic. So we focus to the load bearing straw tower. As for this project, we were instructed to design and build a model of loading bearing tower under a few specifications on its size and weight. The requirement dimension, which has been built with length of 25 cm, 25 cm of width, and 30 cm of height. The building consists of 35 tubes of plastic straws. The base of tower is shaped with a strong cube structure supported by diamond crossing in the inside of it. The upper part of the tower is formed by combining another cuboid with smaller perimeter and higher height. So, and then we continue to the objective. Okay, so firstly is to display and practice knowledge of solid mechanics project given by using any engineering software. So after the discussion of our group, after the meeting of our group, we choose SolidWorks software to make our design because it is easy to use rather than other software. Okay, so the second is to demonstrate effective communication in solving solid mechanics in practical applications. During the project progress, we always make a discussion, even though in a WhatsApp or in the Google Meet, to make our communication skill increase. And the third one is to design and construct the most structurally efficient straw tower capable of supporting a standard load. Okay, so I continue with the other presenter. Thank you.
Assalamualaikum. My name is Siti Nurshaqila Natasha. I will present for literature review. Okay, as we know, the literature review is the planning and design for our prototype. Students will apply a solid mechanics concept to solve problems that improve the build work, including the design of buildings, bridge, and other structures. During this activity, student teams act to design and build model straw towers, taking into consideration limited materials, time, rule as they are brainstorm, design, build, and improve their structures, and also will investigate all topics that have been studied in the subject of solid mechanics. The finding for our prototype is first, stress and strain, second, through stress and strain, third, beam deformation and deflection, fourth, shear and moment diagram, fifth, bending stress in beam, and the last one is the structural integrity and failure. Next, the capability of a structure to sustain a projected structural load like weight, force, and else without breaking, as well as the examination of previous structural failures in order to avoid failures in future designs. For our prototype, we are developed a design solution. We have added trusses on each floor of the tower, so that is stronger and can withstand heavy loads up to 20 kg and above. Not only that, we also made a block tower design with a different size on the ground floor and relative small size on the second block tower, which is on the top floor. The load-bearing superstructure of a truss bridge is made up connected components that usually form triangular units because it makes efficient use for resources. A truss bridge is cost-effective to construct.
Okay, good morning to Puan Nuraini and my fellow friends. Today I would like to discuss about the methodology in our project report. So let's see what we did in our project. The conceptual of the straw load bearing design. The design idea tower is the product of extensive research and analysis of the numerous sorts of straw braces that are feasible. We create and build a good tower form by using adhesive according to the direction to obtain maximum strength and weight of the load. So there are three major parts to ensure that the tower is in good form. The first is joint, second is form, and the third is bracing. So let's see what is joint. Joints is an appropriate connecting method for holding the structure together so that a greater weight can be borne. We held the joint together using glue and double-sided tape. And the second one is the form. The shape of the building is determined by the forms utilized as its foundation. So we tried the roof truss system to build the load so that the tower is more stronger and can withstand more weight. And the third is bracing. The load is distributed evenly across the proper portion and powerful bracing, giving the structure stability and strength. So we also conduct the test and result using placing more weights on the tower to see whether the tower can withstand the weight. So first we put 7 kg on the tower to see whether it can withstand that 7 kg or not. So for 7 kg the tower can withstand, so the durability is pass. The second one is 12 kg, the tower also can withstand the 12 kg, so it is pass. And the third, we put 17 kg on top of the tower, and we can conclude that the tower can also withstand the 17 kg, so it is also pass. And the fourth, we placed 22 kg on the tower, but the tower fails to withstand the 22 kg. So we can conclude that the tower can withstand 7 kg, 12 kg and 17 kg, but it can't withstand 22 kg. So from this we can conclude that the tower must be in good condition and must be more stronger to withstand more weight. So that's all from me. Thank you.
Okay, first, as you can see in the table, we can see the table is 7 total weight. For when we add the load, it became 12, and we add another load, it became 17 kilogram, and we add the third load, it became 22 kilogram. For the durability, we can see this. The first one passed the durability. The second one also passed the durability. The third one also passed the durability, but the fourth one did not pass because the model cannot hold much longer the weight of the load. Okay, and the weight the model crumbled, fall down. Okay, as you can see here, table load and stress, and the table load and strain. Okay, the calculation for both of these table is below. I will explain later. Okay, next. We use the mass weight we using we according to the table above. Okay, next, if calculation for area is width times base equal to 0.0625 m square. Okay, next a formula for weight, which is weight equal to mg. Mg is mass and g equal to gravity. We substitute the mass into the formula while the g is still the same, and as you can see, all we got is that. Yes, that. Okay, next is stress. Stress formula for stress is force over A. We got 0.0625, and we use the data we get from weight, and we substitute into the formula. We get the answer for stress. For strain is search our electricity. Electricity we have 1325, and stress we just take from the other table and we put into the formula. Okay, next is column calculation. For this one, formula is I equal to BD cube over 12. We substitute, we got the answers 3.255 times 10 to the power 94. Next, we find the PCR10 and the K is 2. The formula we can see pi square 2 and the answer is 7.09 mn. Next, bending moment. As you can see that the answer is that. Next, more circle. C equal to 0.125 mqm. Okay, we can see the axis. All answer will be in kilopascal.
We continue our presentation about how we make our tower. Firstly, we must know the material and the tools used. First, we have straw. Second, we have sellotape. Third, we have scissor. Fourth, we have long ruler. And lastly, we have marker. The first step that we did to make our tower is measure the length. We can use the ruler to get more accurate value. Second, mark the place to be cut. We can use our marker. And third, we must cutting. Next, we make a pole with 4 straw. Okay, combine 4 straw with the sellotape. We do it again until the number of pole value finish. Lastly, we must combine all. We follow the design that we did. We do it until finish. This is our tower. The height is 33 cm. The length is 26 cm. The width is 26 cm. And the mass is 0.3
For the conclusion
kilogram.
of our prototype in group 6, students learn about solid mechanics and work through each step of the engineering design process that prepare from the challenge of designing and building a straw tower as tall as possible in a given limited time and
kilogram is the maximum weight they can be
Students
supported
also
by
examine
our
the
straw
calculation
tower
of
before
each
it's
angle of
deployed.
the tower using the
That's
terms
all
in the
from
lesson that we have learned in. Students also learn the higher the structure, the more likely it is to drop in the peak challenge for the tallest straw tower. Students also apply what they have learned and follow the steps of engineering design process to make the model tower as tall as possible in time. Material and building constraints, reflecting real world, engineering experience in designing solution within constraint. Students can also learn the problem that occur when producing straw towers by using the tactics that have been learned in the subject. Students also, when they build the straw tower, they also use for the SolidWorks to design the our prototype. Even students can solve it well and can solve the problem successfully. Alright, that is from us. Thank you. Thank you for watching.